Welcome to Study Loop.
Okay, so in this video we're going to answer question 156 from chapter 17, which asks us to derive the Henderson-Hasselbalch equation. It actually asks you to derive it as a group, taking turns, but since it's just me, I'm just going to derive the Henderson-Hasselbalch equation. So the equilibrium that we have present in a buffer is that between the conjugate acid and water forming the conjugate base and hydronium ions. So the the equilibrium constant for this reaction is just the Ka of the acid, and that's equal to our products divided by our reactants. So that's A minus times H3O plus divided by AH. And we're going to start out by taking the negative log of both sides since we want to relate the pKa to the pH. So taking negative log of the left-hand side, the Ka is just going to give us the pKa. So we have negative log of Ka equals negative log of A minus divided by AH times H3O plus. So negative log of Ka, that just gives us our pKa. And then we can break up this logarithm on the right-hand side into two terms. So the logarithm of a product is just the sum of logarithms. So we have minus log of A minus divided by AH minus log of H3O plus. Negative log of H3O plus is just the pH of the solution. So pKa is equal to negative log of A minus divided by AH plus the pH. And then we can just solve this for the pH by moving our logarithm term to the other side of the equation, and we're left with pH is equal to pKa plus log of A minus divided by AH. And that's the Henderson-Hasselbalch equation.